Hello students, today we are starting a new chapter, pair of linear equation in two variables. This is the third chapter according to NCERT book of class 10th. We know that well, the linear equation in one variable, it means an equation which contains only one variable. Standard form is ax plus b equal to 0. Similarly, now we discuss about the linear equation in two variable, pair of linear equation in two variable. So, since ax plus by plus c equal to 0 represent linear equation in two variable. This is the standard form. Ax plus by plus c equal to 0 represent linear equation in two variable. So that a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0 represent pair of linear equation in two variables. If ax plus by plus c equal to 0 represent linear equation in two variable, because here two variables are used x and y there. Similarly, a1x plus b1y plus c1 equal to 0 with a2x plus b2y plus c2 equal to 0 represent pair of linear equation in two variable, where a1, a2, b1, b2 are real numbers. Also, linear equation in two variable ax plus by plus c equal to 0 always represent straight line graphically. If we draw a graph of linear equation in two variable ax plus by plus c equal to 0, so we get straight line graphically. Similarly, suppose that if we draw a graph of ax plus b equal to 0, suppose that we draw a graph of ax plus b equal to 0, this is also a straight line. So what is the difference between this and this? Because this equation also represent the straight line and linear equation in one variable also represent the straight line. The difference is that linear equation in one variable represent the straight line which is parallel to x-axis or y-axis, depend on the variable x and y. Similarly, linear equation in two variable represent the straight line. It may be passing through the x, intersect the x-axis, intersect the y-axis, or both the axes. So this is the difference between the linear equation in one variable and linear equation in two variable. The graph of linear equation in one variable is always a straight line parallel to x-axis or y-axis, depend the variable x or y. Similarly, the linear equation in two variable represent again a straight line, but this straight line passing through the x-axis and y-axis both. Now, solution of a linear equation of two variables. Let x equal to a and y equal to b are two values, and these values satisfy each of the equation of pair. Each equation of pair, then x equal to a and y equal to b are called solution of pair of linear equations. The next topic is solution of a linear equation of two variables. Suppose that two real numbers, the pair of two numbers are given, x equal to a and y equal to b. If these two values satisfy each equation of the pair, if we put x equal to a and y equal to b and this satisfy equal to 0, and again this value satisfy this equation, so if these values satisfy each of the equation of the pair, then we can say these values are the solution of the pair of linear equation. Now the next topic from this chapter, consistent system. A pair of linear equation in two variable is said to be consistent if system have first a unique solution, and second infinite solution. If a pair of linear equation is given, that means two equations are given, a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. This is the theoretical format of the linear equation in two variable. At the place of a1, b1, c1 and a2, b2, c2 we have the numerical value. So but we are taking the standard form. So if we have two equation in the pair of linear equation in two variable, and the system, because the pair of equation is called the system. Single equation is called linear equation in one variable, but the pair of linear equation in two variable is known as the system. So a pair of linear equation in two variable is said to be consistent if system have a unique solution. Let me look it. There are two categories. One, a system have a unique solution. That means if we solve both the equation, we have the single value of x and single value of y. Either infinite solution, that means in this case x and y have the more than one value. So this category, in these two categories, system of equation is called consistent system. Next, inconsistent. Inconsistent system. A pair of linear equation in two variable is said to be inconsistent if system has no solution. So if the pair of linear equation have no solution, then we can say the system is inconsistent system. Let a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0 is given pair of linear equations. Then the condition number first. Then system will be consistent and having unique solution. A1 upon A2 not equal to B1 upon B2. A1x plus B1y plus C1 equal to 0 and A2x plus B2y plus C2 equal to 0 is given pair of linear equation, the system of linear equation. Then first condition is that system will be consistent, that means in this category, we are moving in this category, will be consistent and having unique solution, this category and this part. If A1 upon A2 not equal to B1 upon B2. This is the condition. Second, system will be consistent and having infinite solution. A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. If the system have infinite solution, in this condition A1 upon A2 equal to B1 upon B2 equal to C1 upon C2, and these values can be obtained from the linear equation in two variables. And next, third condition, system will be inconsistent and having no solution. A1 upon A2 equal to B1 upon B2 not equal to C1 upon C2. If system is inconsistent, then the condition is that A1 upon A2 equal to B1 upon B2 not equal to C1 upon C2. So this is the theoretical representation. So which condition in which the system has unique solution A1 upon A2 not equal to B1 upon B2. System will consistent and having infinite solution A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. And similarly, system will be inconsistent and having no solution A1 upon A2 equal to B1 upon B2 but not equal to C1 upon C2. So these three conditions are very important conditions by which we can recognize the pair of linear equation have the solution or not have the solution or have the infinite number of solutions. Now we discuss about the graphical representation of pair of linear equation in two variables. Let a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0 is a pair of linear equation in two variables. Pair of linear equation in two variables. And condition 1, a1 upon a2 not equal to b1 upon b2. This is the first condition. System of linear equation is given. a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. This represents the system of linear equation or the pair of linear equation. And the first condition is a1 upon a2 not equal to b1 upon b2. That means this implies that equations represent intersecting lines. If a1 upon a2 not equal to b1 upon b2, that means these two equations represent intersecting lines. Second category, a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. This is coincide, represent equation coincides lines. And third category, if a1 upon a2 not equal to a1 upon a2 equal to b1 upon b2 not equal to c1 upon c2. In this condition, equations represent parallel lines. So in this case, equations represent intersecting line. In this case, equations represent coincide lines. In this case, equations represent parallel lines. Example for first condition. X plus 2y plus 4 equal to 0, 2x plus 3y plus 5 equal to 0. Here a1 upon a2 not equal to b1 upon b2. a1 upon a2 not equal to b1 upon b2. That means intersecting lines. For second condition, x plus y plus 3 equal to 0 and 2x plus 2y plus 6 equal to 0. Here a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. Coincides lines. And for third condition, x plus y plus 4 equal to 0, 3x plus 3y plus 7 equal to 0. Here A1 upon A2 equal to B1 upon B2 not equal to C1 upon C2. So this is parallel lines. This is the condition for parallel lines. So in numerical equation, first we select A1, B1, C1, A2, B2, C2 and check that. If this condition is verified, we can say the lines are intersecting line. If this condition is verified, then we can say the lines are coincide. If this condition is verified, then we can say the lines are pair of straight lines are having parallel lines. Okay.